Hello, y'all.
Hello, y'all.
What's going on? Welcome back.
I'm trying to do the Johnny Cash intro. Hello, y'all. This is the man in black. All right, so if you didn't see our previous video, we done bought a CNC machine. Now we've already got one that's it was kind of like a already ready to go one. But we went and bought this one because we want a heavy duty CNC machine. And so we found this one. Donnie went and bought it. So our previous video was Donnie hauling butt down to, the devil went down to Georgia
Looking for a soda stick.
and found this CNC machine. So the reason that we like this one is it's much more sturdy than our old one. We're going to take these wheels off so it's more sturdy. And then it's got a vacuum table. So we have no clue who made this thing. So if you know, if you can tell who made it, leave your comments down below and let us know who made it. It came with a whole bunch of parts and it was all taken apart. And the guy basically just had it as the table and then a whole box of parts. And so the gantry was not on it. So Donnie figured it all out and put it back together kind of how the gantry goes. And when we did, we figured out basically what happened to the thing. So it was still together. Wasn't it still together?
No, this was in a box.
Okay. Basically, this pinion shaft, there is a gear that mounts on it, and it had completely sheared off. And so this is what the one looked like that was in it. I wonder why it was hollow, Donnie.
I don't have no clue.
So this sheared off. Okay. Now, because we don't know who made this thing, you can't order any parts for it that are designed specifically for this machine. So, fortunately, the other side was still on.
There's the other side.
There's the other side. And so we were able to take it all apart, check out the pinion, and then figure out what happened. So basically what happened was the whole end of the shaft had broken off. And so up there is where there was a gear mounted, because this machine uses rack and pinion gears on the side. So there are little teeth. This is the rack, and then there's a little pinion gear that goes in here and turns on it. So this is the pinion gear that goes on that shaft. Now you can see how the wear pattern is, that it doesn't go way in. It kind of went like that. And then as the motor turns up and down this gear, it moves the gantry up and down the X-axis. Okay, so basically we bought this thing. It's completely disassembled. It's broke. We got a pretty good deal on it, but the reason we bought it is because it's heavy duty and has potential, right? So the guy had taken it all apart, wasn't using it. He bought it with another table router that he wanted, and had all of these as parts. He was hanging on to it because he liked the vacuum table. So if you don't know anything about CNCs, basically a computer controls the movement of the motors, but on this particular model, by moving up and down the table, moving this one this way, and then moving that one up and down, and it can cut out on a flatbed like this and basically do a sheet of plywood, or particle board, MDF, whatever you want to call it, whatever, sheet wood, sheet goods. So we need this because we're cutting out arcade game cabinets and stuff. I mean, it's just something we like messing with. We're blah blah blah. So our old machine is just a little slower than we want. So this one, since it's heavy duty, we're hoping that it can handle more speed, beefier motors, stuff like that. Okay, so like we said, we put it all back together. Show them how the gantry moves, Donnie. Smooth as silk. All right, now the way it moves is it slides on these slides here, which actually hold all the weight. So the gear is not actually holding any weight. It just turns, and it's what actually moves it to position, but this slide is actually holding up the weight. So you don't have like a ton of weight that you're trying to move with the motors, right? Because it's supported by the slide. Donnie's over there messing with the other side. Okay, and now here is the y-axis. And the Y, it was still hooked up, so this is basically how the thing works. It has a belt on a large wheel, a motor mounts here, has a gear on the end of the belt. The gear turns the other pulley, and as it turns, it can position this wherever it needs to be. All right. So, pretty standard setup for a lot of these. So that one is still put together how it should have been. And this one over here, I'll show you, we've put back together how it should have been. And then I'll show you what we're going to do right now, just because we thought you might want to see it. So here is this side. Now on your x-axis, to move this, gantry that has some weight to it, a lot of times they'll put two motors. So this will probably be like the A side, we'll call it. And we'll call that one the X side. So there's a huge NEMA 34 motor that mounts here. Ours is going to be about this big though, because we'll talk about all that in a future video. But the motor is going to mount here with a gear sticking out here. And then the pulley will be there. As the computer turns the motor, it will turn the belt, which will move the axis wherever it needs to go to by counting the steps. So this side, back together. What do you think?
Yes, it is.
And this one, it's still together.
Still together.
That one over there is not. That's the one that broke. So, since we can't order parts, how in the world would you go about fixing one of these? And why would we buy something that's completely disassembled? Why did you buy one that's completely disassembled, Donnie?
Because I know people.
Well, Donnie knows people. Okay, so the problem was the end of it was broke off, and you cannot order these things because I would call that a pinion shaft, but Google pinion shaft and see if we don't even know the part number. Google CNC pinion shaft and see if you find this part. You just can't do that. So, like Donnie said, he knows people. So he called people, and that occurred. Now, how did that occur, Donnie?
Because I told him I wanted one of them. I took him that and said, make it.
Yeah, we took this to a guy that has he's a hobbyist, basically. But he's an old school machining guy. And he said, no problem.
Yep.
What did he say, Donnie? Give me a, there's a lot of engineers that watch my channel and your channel. Okay, so give us the impression of how the guy acted. Act like you're the guy. And so I'll act like I'm you. I need about 5 of them, bud.
That's some hard stuff.
Yeah, I don't know what it is. It don't have to be hard.
Some hard stuff. How many you need?
I need about 6. It depends on the price, but probably 6.
When you need them by?
Just as soon as you can make them. Ain't no big hurry, but sooner than later.
Okay, I'll see you tomorrow.
So that's how the guy did it. So, he just made it happen. He said, I think I'm going to make this out of cold roll, didn't he?
Yep.
So it's very simple. This end is 5/16. Now 5/16 is 5/16 of an inch for you metric people. And then this up here is 3/8, this whole end. But there are 2 little C-ring grooves cut in it. Okay? Easy peasy, he said. He said there wasn't nothing to it. Okay, so we got that done. And then we needed the bearings. So show them the bearings, Donnie. This little plate is on the end. Let's show them on that.
Okay.
So there is a bearing mounted in this plate. So we messed around with it and we were able to figure out that the inside diameter is 3/8. And then the outside is, what did that end up being?
Don't know. Oh, it's 3/8 by 7/8.
7/8. Outside diameter is 7/8. That's not metric. I know. I can't do the conversion. That's just what they call it over here. So that's a pretty standard bearing size. So we were able to order these beautiful made in the USA bearings here. Now, by the way, they are companies. The only country we have a problem with stuff being made in is China. If it don't say China, we're cool. So it could say made in Germany. That would be awesome.
Yeah.
That would be some damn good ones. If it said made in the UK, we'd be very happy. Made in Canada, that's cool. Made in Mexico, just fine, right? But these are made in the USA. Now these things, where were these made, Donnie? Down the street, right?
Down the street. As local as you can get it.
They're made very local. So this thing, we think, this might have been made in the USA, the whole thing. It looks like it's from about 2000. I don't know. One of these had some markings on it that the piece appeared to be from 2001.
But they could have done just like I did.
Yeah.
Went right down the street and had it made.
Yeah, they might have had it made. So we're going to, Donnie's using his bearing remover. We're going to go ahead and put this last piece on and we'll see how it all fits. So we put the nice new bearing in it, maybe.
Plastic.
I'm going to use his bearing installing kit. Bearing is installed.
Okay, now
Okay.
I've already put the C-ring on.
Yeah, so we got a bunch of these shafts. We made 6 of them. So the little C-ring, that might not be made in America. Let me go see where that's made. We're trying to get as much made in USA stuff as we can. Or not made in China. Okay, so let me see.
That's the one that come off this machine.
This is made in Taiwan. Oh, it's the one that came off the machine? Oh, okay, yeah, put that one on there.
See, I got another one that's right here.
I need some
Come off the machine.
I need some 3/8 C-clips that are made in the USA or anywhere but China. India would be fine.
Okay, so you got to put double bearings on. Okay.
Yep.
Now that's going to go in here.
Yep.
So you need your double bearing. And then
We got another little issue. So here's the next part.
this gear we bought.
Show them the other one that we ordered. Is there one? Did he give it back to us or did he trash it?
He gave it back to us. It's right here.
So we had the broke off. No, we didn't have the broke off gear. We had one good one from the previous thing. So if you look at it, I can't really get a part number off of it. I couldn't tell what it. Whoop. But after messing around with it, I assumed that it was 14 degree teeth. You know, there's 14 and 20, but most of the older stuff's 14. So I assumed it was 14. And then it's, the rack itself is 3/8 by 3/8. And the gear is meshing with even less than that. It's just how it is, okay? So I started looking around. And I figured out, and it's a 12-tooth gear, right? And just by the measurements, and you know the inside is 5/16. The outside, just by measuring it, I was able to find this bad boy. Pretty much the same thing, but the face, it's just a little smaller size as far as the length, but the actual teeth appears to be the same. So it's just a little spur gear, right? So they make these brand new. So I ordered it, but here's the problem. There's no set screw. There's nothing to hold it on. I don't even know what the hell this would be for. Explain to me, Donnie, why you would need a spur gear that you can't get to stay stable on anything. I don't understand what they were doing. I guess you're supposed to machine it.
Or a threaded shaft, maybe? But it still seemed like it spin.
So I don't know what's up with that. So I ordered it. I got it in. I figured, you know what? I realized the error of my ways. I'll make sure that I find one that is one with a set screw, a freak, because the old one has a set screw. So I'm not doing that because I want to do a set screw. It's just that's how they did it, right? So then a keyway would be better. So I ordered another one, got it in, and they sent me the wrong part. It did not have a set screw. So these things are running like $25 a piece.
That was a second.
Right? So this is the one I get in. Same freaking part, no set screw. Thank you, buddy. Appreciate it. You know, they're doing me wrong, people. They're doing me wrong. So then I order the right one, right? So I ordered the one with the set screw, but look, it's not tapped. So it just has a hole in it. So that's 3 that didn't work. So finally, I ordered these. I got one of these in. See, I don't know, man, if that's the right. I don't know, Donnie. I don't like how those teeth look. Look, they look different than these. See, to me, that looks different. This looks like the 20 pitch, but I don't think it is. Yeah, I guess it's the same. I don't know. Whatever. So anyway, we get these in, and then we take it to our buddy. He taps and installs 2 set screws for us. So this is a fairly good match to that, although I'm not so sure about the width of the teeth, but we'll see how it works. So that's what we're working on. That's what we got. So we're trying to go ahead and put this thing back together, if we can get it to focus. Trying to put this thing back together, and
So
there we go.
our next problem is the height difference.
Yeah, it's not the same length and all that.
So what we got to do, we got to put 3 washers on here.
Put a few little 5/16 inch washers, space it out a little bit.
And that's going to get my gear up to where I want it. I got to loosen my set screws. Loosen this one, try not to lose them. Put that on there. And I got to loosen the set screws some more.
We're going to turn Donnie into a CNC operator. He's already operating the other one, but
get it down on there, and that puts me about flush there. That's what the other one does. So now I got to put my set screws back in here. Make it bite in pretty good there.
so it don't spin, which there's not even a flat spot on the shaft, so we're curious if that's going to hold the torque if we're running at like high RPMs.
Next thing we're going to do is have this milled if it don't work.
Yeah, if this doesn't work, what we're going to do is have the guy just mill the entire shaft with the gear milled into it.
Now,
Make a true pinion shaft.
this goes in like so. You got to get it lined up here. There you go. That's lined up. Then we got to put this wheel on here.
Oh, show them the mark. Pull that wheel back off if you can. See the ring? That's when the thing crashed and it broke the pinion shaft. The wheel actually hit the side and rubbed. But it does not rub. It's just close. So that wheel is labeled 60XL. So XL, I think, is the sizing of it, and the 60 is the number of teeth because they do gear reduction. So it looks like the actual motors would have had probably a 12-tooth pinion on it, and then it goes to that 60 tooth to give you a 5-to-1 reduction. But then the actual spur gear is back to 12. So really, it kind of, let me think. Oh yeah, then you have to figure out the length. So you have to figure out how far do you get out of 12 teeth. And I think it's almost 3 inches, something like that. So for every 5 revolutions of the motor, you get about 3 inches of movement on the pinion.
So then you got to put your other set screw, your other whatever this
E-clip.
thing- E-clip. That's it.
C-clip. I think it's a C-clip.
No, C actually looks like C. We got some of them over there.
How about as an E? I'm not sure.
Okay. Okay, now we're going to take the screws out. And I already set this one in there. Now, that whatever clip that is going to keep that thing from walking out here. And this is milled so the bearing can't come out.
Don't do it! Don't do it, Donnie! Don't do it!
The belt.
Okay, so I ordered a bunch of belts. Hey, where were them belts made, Donnie? Let's see a close-up of the logo on that sucker. God, his phone don't want to cooperate. We're too far off the ground. Here, put it up here where they can see. These freaking phones that are made in China. Gates Power Grip, made in the USA. Made in the USA belt. There we go. So basically, that was the belt that was on it. We just ordered some that were the exact same part number.
So that goes on now. And then, this will only go on one way. See how it's off?
Yeah. He was just showing you that to show you that it would only go on one way.
No, I screwed it up. I went on the wrong way.
It's a pretty cool little design, but again, we don't know who made this or what company it was or whatever, but it seems like it's a pretty cool little setup. I don't really like the way the pinion gear meshes with the rack. I don't really like that because it don't go, it's only 3/8 and it's only in there about halfway because they put freaking bolts in the way. I'll show you that too. But we're hoping we can get some speed out of this thing. So, one revolution is going to get you about 2/3 of an inch. One revolution of the motor. So if you're running the motor at, let's say 900 RPMs, you would get 600 inches per minute speed out of it, which is faster than we really need to go. But that would get us plenty of speed. So can the motor do 900 RPMs and still maintain some torque? Well, that's a whole other thing. So whenever you buy the motors, you have to be careful. If you get, a lot of the motors are really high torque, but it drops off real quick. So once you get up to any kind of speed, it doesn't work for you. All right, so here's what we're gonna do. I'm gonna hold it, Donnie. And you just wiggle the thing a little bit. Just, okay, move it less. I can feel the wheel moving every time he does it. So I think it's pretty accurate. Let me show them that pinion gear on this side, if they can see it. I'm gonna pull our guy, I don't know if it's AVE or AVE when he says focus you. So here are the slides on the rails. This thing will not focus to save its life. Okay, so see here on the gear, how they have that freaking bolt sticking out? So because of that, you can't let the gear go too deep in there because of those. We may end up changing those fasteners so that we can get our gear farther in there. Because right now it only meshes with about half of the 3/8. Yeah, that's much better, yeah. So you see that? Why would they design it like that, Donnie? Why did they do that?
I don't know.
We don't know who did it. We may find out this thing also was made in China. We don't know. I don't think so, though. It looks too... Now, people are going to tell us, Donnie, that they make plenty of good stuff in China. That may be true.
That may be true. I just ain't found none of them.
You can't discern what's the good stuff and what's the bad stuff, though. So you can see that it only meshes about halfway, but that's because we can't go out too far because it'll hit those bolts as it goes down. I have no clue why they did it like that. But, to the best of our ability, I think we've done a reasonable job of fixing that. It's pretty much on there. Now, I'm moving it just a little bit, and I can see that wheel moving just a little bit. That's pretty freaking solid, man. I don't know. I think we might get away with that. Well, folks, we think we missed we ran into our first snag. We've been sitting here looking at this, and I think we got the wrong gears. So I was saying that, so they're 20 pitch, diametric pitch gears, and the pressure angle is 14.5. But here's the thing. I just guessed that they were 14 and a half. And the reason that I guessed that is because that's the older pressure angle of the gears. So they all used to be 14 and a half. I thought that changed around 2000. That changed around 1980, right? So I was thinking, oh, this is an older one. It's going to be 14 and a half. But it's not that old of one. It's only like 20 years old. So the 20-degree pitch pressure angle, 20-degree pressure angle, has been around well before this thing was made. So we don't have a way to measure it. But if you look, this gear, this is the only original we have.
Oh, this is the original.
Oh, this is the original that we have. And it seems to mesh really well in there. This one, I know is a 14 and a half because I ordered it that way. It makes more noise and it doesn't seem to, it's jerkier.
The way
This one's much smoother.
the way I'm understanding it, these gears or these teeth are V'd at 20, and at 14 they got a flat bottom in them.
Yeah, the bottom of the rack, it looks like, for 14 is more flat on the bottom,
Which is this.
which is more like this. See how it's more flat on the bottom? These is more rounded on the bottom, and it's just a straight up, they just look pointier, basically, if 20. 14, now, this isn't exactly the same because it's on a spur gear instead of being straight. But these are basically the same thing, it's like an infinitely sized gear, basically. It's like a trillion tooth gear, basically. So our one original, this one, if you look, the damn things are more pointy. Probably because it's 20 pitch. We ordered 14 and a half pitch. See the difference? Now the reason we're thinking that is because when we roll this, it's kind of smooth, but then you can hear it, and it's just not quite right. Pull that one over, Donnie, so they can see how smooth that one is. So this one we haven't taken apart yet, so it's still all original. And she's smooth, people. Just very little friction, no jumpiness, because it has the original gear on it. So I think I screwed up and I ordered 14.5 pressure angle, which are not compatible with the 20 pressure angle gears. So after all that trouble, we think that's what's going on. I was wondering why those were so hard to find. It could be because 20 pitch is usually 20 pressure angle. All you CNC guys, I'm sure, know exactly what I'm talking about. But if you're not into CNCs or machinery, you probably have no clue what we're talking about. But it's basically the angle of degree that the tooth is, the sides of the tooth. What we're saying is we think this one, which is one of the original ones, put the light up top, Donnie, so that they can,
Up here?
like, so we're saying that angle there matches because this is the original gear. But that this angle, it's so hard to show this. That this angle is off a little bit, and that's why it's not meshing quite properly. Now when these do mesh, they don't really go all the way in, but they're not supposed to. So there you go. So I don't think that's right. And here's our original one. That actually looks pretty good. That one, not so much. So I think we've got the wrong pressure angle on it. Donnie, we're going to have to order all new.
I got a guy.
He can't make a 14 or 20, Donnie.
He can probably order just as good as we can.
Oh, yeah, you know what? Boston Gear's in town, isn't it?
Uh-huh.
All right, so we're gonna see if the guy can order those, but that's all right because we have to do another video on this thing. What we're gonna do is, we've got to do a video on all the electronics and stuff. Basically, it didn't have any of the electronics with it. We've got a couple of the motors, but I'm ordering new motors. I'm just waiting for them to come in. So we've ordered a lot of the electronic stuff. So we're going to be doing that too. But we've got to get this where it moves pretty smooth. I mean, this is just running into, it's not quite right. And so we've looked at the rack all along. It looks fine.
Looks right, yeah.
It doesn't look like there's a problem where, you know, something's screwed up here, so it's getting a rough spot. So it'll roll decent for a little while, and then it gets screwed up. So we're going to check into that. So we'll see if the guy can get us the exact same thing, but in 20 pressure angle, 20-degree pressure angle.
He's a CNC guy, so he'll probably be able to look at this gear and say, yeah, that's a XYZ 2762, and bam, we've got it.
We're going to get off of here and text him a picture and just see what he thinks and see what we can do. So we'll do another video showing the next part of it. But leave your comments below. I bet a bunch of y'all know all about it too, and you can tell us what you think and what we need to do, where we're going. That's the electrical enclosure over there that we're making. Just haven't got there yet. But there you go. What do you think, Donnie?
I think you ought to give us a thumbs up for filming it, even though we did get the wrong part. Give us a thumbs up for filming it. Subscribe to the channel if you hadn't already, and we'll catch you on the next one.